Hello, everyone. Welcome to GraphQL training. My name is Abir Nawaz. I am a senior solutions consultant at Ataccama. Today, I will be presenting to you about GraphQL and how it can be used when working with Ataccama ONE API. We will start off with a very brief introduction to GraphQL. Then, we will compare GraphQL with REST API to see and understand the differences. Then I will show you some key concepts of GraphQL and how it is constructed. Then I will talk about some practical and common use cases and give you a live demonstration of how we can use GraphQL to achieve these use cases. So what is GraphQL? GraphQL is a query language and server-side runtime for APIs. It allows the client to specify exactly the data they need with a query. It is fast, flexible, and developer-friendly. It minimizes the amount of data that need to be transferred over the network and enables front-end and back-end developers to work independently. It is not tied to any specific database or storage system. It is backed by code and data, so in a sense, it is database agnostic and can be used in any context. In order to understand GraphQL a little bit more, here is a simple comparison with REST API. GraphQL uses client-driven architecture, which means it is localized within client environment, giving the client more flexibility, where REST API uses server-driven architecture, which means the client can only interact from far away, and managing and manipulating the data is done on the server. GraphQL is a strong type system using schema, which provides flexibility to the clients, where REST API utilizes endpoints, which cannot be very flexible, and the client has to rely on server-side development heavily. Also, GraphQL allows specific data fetching with single API call, where in REST, you generally require multiple API calls because of fixed data structure. Over here is an example of a query achieved by GraphQL compared to REST API. If you look at the left slide, you can see a single GraphQL call that could retrieve the information that we need. From assets node, we are getting fields like ID, URL, and last two comments. For REST API, multiple calls were required for multiple endpoints for the same information. Some common problems with REST API is overfetching and underfetching. If you look at the results of the first REST API call, you can see an additional field here called active, which we did not want. This could be worse when there are tens and hundreds of more fields for the assets node, which we do not need. This is called overfetching. Also, the first result is missing comments, which is why we had to make another call to retrieve the comments for each asset. This is called underfetching. I hope that was a helpful introduction. Now I would like to show you how to use GraphQL in a live demo. GraphQL can be used in a number of interfaces. What you see on the screen is called Playground, and this developer tool comes with the Ataccama ONE module. On the left side, you would construct your query, press this play or execute button, and you would see the results on the right side. The only setup you really need here is the authorization details passed in the HTTP header section. Remember, GraphQL is a schema and type-based query language, so you can see the schema in this tab, where you have all the type definitions. You can download the schema. You can also look at documentation in this tab, which can be helpful in constructing your query. Here is a pre-constructed query as an example, and I will explain the construction of this query. At the very beginning of our code, we have this keyword called query. This is an operation type. In GraphQL, there are three types of operations: query, mutation, and subscription. Today, we will look at query and mutation types only. The next part is the name of the operation, and it can be any name. This name is useful when debugging and looking through logs. Instead of trying to figure out what this query is doing, we can give it a meaningful name. Over here, I begin with my root node that I'm interested in. This is based on a type definition in the schema. Over here, I'm passing an argument. Sometimes arguments are required for specific type definitions, and sometimes they are not. Then I select the fields I want from the root node. I can traverse through and select exactly which of the embedded and reference child nodes I want. One great thing about GraphQL is the content assist or autofill. When you press Control Space, it gives you a dropdown to help you select the fields that are available within this node. Or you can start typing and press the Tab button to autofill. This means you may not need to know everything in the schema or spend a lot of time reading the documentation for basic queries. It is very interactive, which means you can start building a query with some basic understanding of Ataccama's metadata model and knowing what the different nodes and entities are within Ataccama. So once I have a query, I can press the Run button and get the results. Now I know my query and the connection to the server is working. Here you can see all the information from the query. Now let me demonstrate how GraphQL works with some practical use cases. Keep in mind, these are simplified use cases for today's short presentation. However, I hope these simplified use cases can help you understand how the concepts can be applied to more specific use cases. Here's our first use case: how to extract all glossary terms from Ataccama ONE. Ataccama ONE Data Quality and Governance Platform allows you to manage enterprise glossary terms to help you catalog data across your enterprise. Let me show you how these terms look like. Here on Ataccama ONE web application, within the glossary terms, business glossary term section, you can see all the terms and all the different types of terms. And you can see we have a total of 206 terms in the published node. So how do we extract all this information? We can see by going into each term, we have more detailed information like name, definition, and so on. To extract this information, we can construct a query. First, I define my operation as query. I give it a meaningful name. And then I select my root node. In this case, I'm interested in terms. And then I need to select which version I want. For now, I will be pulling only published terms. Now, because I'm querying terms, I know that this is a list of term nodes. In Ataccama Graph, all lists or arrays are wrapped around a technical wrapper called edges. This allows us to get more information about the list. For example, here I can simply select a field called total count which gives me the total count of the nodes within this array. As you can see, I can get a total count of 206 terms. Then I can go into the edges, and for each node of term, I can select a node property like global ID and type. Now, some of the properties like name, definition are versioned, so we must traverse into the version we want. And then we can select the properties of terms in the published version. As you can see, we have constructed here a query for our use case where we are pulling all the glossary terms from Ataccama ONE. We can use this query as API from another tool. We can copy the curl command, and this is what it would look like. And we can send this to our client system where they can invoke this query using curl. We can also use a component developed on Ataccama ONE desktop. This is a component on Ataccama ONE desktop, which uses a JSON call step where we are passing the GraphQL query we just constructed. And this would write into a CSV file all the terms from Ataccama ONE web application. Now let's look at another use case. How to extract catalog items. This is a common use case because once you have profiled your data sources, you may want to extract some of this information out for other systems to work with. For our GraphQL query, the idea is very similar to what we did earlier. We start with a query operation. We give it a name. And then we select a different root node than last time. And this time we are interested in catalog items. We want the published versions. Now, a catalog item has a lot of information. Here, we can really see the power of GraphQL because we are able to specify exactly what we want by selecting the fields with that we need. So let's get some information like name. We can also retrieve information about the connection. This will help us understand the source of the catalog item. Other than node properties, we can also retrieve profiling results of each catalog item. We can also retrieve information about the attributes of each catalog item. For now, let's get the total count of attributes for each catalog item. Let's run this. So over here, you can see we're pulling catalog items from different source systems like Amazon S3, Microsoft SQL, and Snowflake. We're also retrieving profiling information over here. We can limit the number of aggregated results here by applying a limit in this node. So this will get us only the last 2 aggregated results. We can also apply a filter on the root node level if we wanted to narrow down our query to something more specific. We can do that by using a filter. The filter argument takes a string with SQL-like where clause. So let's put something like connection.executor type equals Snowflake. Now our query is filtered only for catalog items from Snowflake source systems only. You can see in the results, all of these catalog items are from Snowflake. Moving on to our next use case, how to bulk import glossary terms from another source. This type of use case is commonly required when your organization already has a library of terms stored in another system and you want to migrate them to Ataccama. This could be a one-time bulk import or a continuous batch import. To achieve this, first we need to create a generic query where we can create a term using GraphQL. Because we are writing to Ataccama database, we will need to use a mutation operation. Generally, a query type operation can be used for writing as well. Similar to REST, a get method can alter the data as well, but as a best practice, we differentiate between read and write operations. Similarly, in GraphQL, mutation is used when altering the data. The structure of the mutation is similar to a query, except we use the appropriate type of root node. In this case, we will use term create. And then we need to pass all the information that we need to create a term. First, you define new object with type. In this case, we want to create a business term. We can pass information like name, my new term, abbreviation, and definition. So you can see over here, we're passing all the information that we need to create a term. We also need to provide some other information like this. And we need to provide some graph-related information like this. So over here, we have the parent information so that we know where this new term can be placed within the Ataccama graph. We specify the parent node, parent property, and parent ID, and some additional details for the terms as default configuration. These are not as intuitive to construct like basic queries and require a little bit more knowledge on Ataccama metadata graph. You can learn about these from the documentations. Finally, we have to select what we want as our response. We want to see if our operation was successful. We can also see what was the result object that gets created. I can get the ID of the object, and I can check all of the information we're passing in our arguments to see if they were created successfully. Once you run this mutation, it creates the term, and the success field is now true. It gives us an ID of the newly created term, and we can check on the front-end web application, and we can see our new term is now created. It is in draft mode, waiting to be published. Now that we have this query, we can use this query inside our client code to bulk import terms. In most cases, the arguments to these fields will be dynamic. GraphQL has a first-class way to factor dynamic values out of the query and pass them as a separate dictionary. These values would be variables, which you can pass in this section over here. Let me show you how. First, we have to replace the static value in the query with a variable name. So let's change this to a variable. Then we need to declare the variable name as an accepted variable at the query operation level. Over here. And we need to specify what is the data type of this variable. And finally, we need to pass this variable in a separate dictionary as a JSON format. We can do the same for another variable. When you run this, you can see it works same as before. And when we go back to our front-end web application, we can see our new term was created. This allows the client to manipulate the variables from the dictionary as opposed to the query itself at runtime. Let's take a look at our fourth use case, how to trigger profiling on catalog items. Profiling on Ataccama can be triggered either manually or scheduled, but sometimes we need to trigger a profiling job as part of a CI/CD process when new datasets are created or updated. This is when we can use GraphQL to trigger profiling jobs on Ataccama automatically based on another external event. Here's an example of a query where an existing catalog item needs to be reprofiled. A query on catalog item node is used with a special field called profile, which accepts arguments in order to trigger a job on this catalog item. In the argument, we're passing which default credential to use and the configuration ID, which represents the type of profiling job to trigger. In the results, we select the fields that we need to see as response to know more information about the profiling job itself. Once I run this query, it will trigger the profiling job on the web application, as you can see with these pop-ups. Notice we have a GID field over here, which represents the global ID of profiling job, but this is not easy to understand. So what we did is used an alias to rename this field to something more understandable on the client code. And this comes in the response of the query as well. This is called alias. Let's look at our final use case, how to extract data quality results from monitoring projects. So we query into monitoring projects node. We get some information we need, like global ID. We can get the name of the monitoring project. And then I can get something called DQ project results over time. I need to pass a selector argument, leave it blank for now. And then I will get information about the results of the data quality evaluation for this monitoring project. Get some information like processing ID, started at, and the results. So now you can see this query returns all the monitoring projects, including their data quality results. In this monitoring project, we have multiple results at different dates. Now let's say I want to narrow down our query to give us results from a particular date range. We can do that by using the time range in the selector. We can specify from when and to when. The format of the date time can be copied from here. So let's say I want to filter our query to give us results from March 21st to March 29th only. Now, when I run this query, you will see that I have a result from March 24th, I have a result from March 24th as well, and that's about it. It filtered out any other results from the monitoring project that is outside the time range. This query can be used to extract data quality results from Ataccama and present it in an external data visualization tool. I hope the demonstrations for these use cases helped in understanding GraphQL better and how to use it. That concludes our training session. I hope you enjoyed it. Thank you for joining. Take care. Bye-bye.